Bluemvmt is introducing a platform as a service to help solve the problem of IoT data integration. In our research, we uncovered 3 challenges that exist. First, incompatible or cumbersome data and communication formats across the device and machine-to-machine landscape limit interoperability. Second, the data that does exist are often locked in data silos. And third, there are issues around data ownership and usage, which inhibit data sharing. To solve these challenges, Bluemvmt's orchestration editor, BlueFlow, extracts, transforms, and loads any dataset effortlessly. Our AI-enabled search eliminates the friction associated with discovering and sharing data. Our Blue AI data warehouse introduces an exciting new generative AI feature, Data Insight AI, which uses natural language to reduce the time and expertise needed to discover actionable insights. And finally, our sidecar technology connects the data and results to the user's favorite analytics and data visualization apps to turn the insights they generated into action. That's the setup. Let's dive in, and I will show you how this all works. Let's begin with BlueFlow. This is a control flow that provides the user with the ability to extract, transform, and load sensor data into our Blue AI data warehouse. BlueFlows are no-code, low-code control flows that are highly configurable and customizable. Each BlueFlow is made up of categories of controls, such as data formatting, alerts, events, user-defined math, or UI protocols. As you can see on the screen, the user drags and drops raw data from a sensor onto the canvas and applies the category of tasks to that data. BlueFlows are used to apply debugging, data cleaning, or smoothing the data before the user applies it in the Blue AI Insights engine. In this example, our sensor uses a protocol called TCP/IP, which is one of several communications protocols we support. The data loaded can first go through a debugger, and this data will come through in the side panel to the lower right. We are then going to take that data and run it through a function to convert the raw data into a formatted file, but first I may want to clean the data. Once I have converted it to a CSV format, I'm going to write this to a file so I can publish it out to an API to import it into our Blue AI data warehouse. I can also clone this flow very quickly, and then I can have other sensors connect to it, and all of the same transform steps and output can be applied to another type of sensor. Now let's turn our attention to the Blue AI data warehouse. The way to think about Blue AI is imagine you had a generative AI copilot that can help you find the data you need to solve a particular problem, analyze that data without the risk of returning hallucinations, while providing valuable insights and additional suggested paths of inquiry, all the while working alongside other applications like R or PyTorch or other shared platforms, delivering extremely low latency, allowing you to quickly and precisely land on the essential insights to inform your decision-making. Let me walk you through the Blue AI homepage. It all begins with databooks. A user will begin by searching for or uploading the data to be included in their databook. Think of a databook as a digital notebook. It is a way for you to organize your information so that you could rapidly connect all of the data sets and results directly to our AI Insights engine. Also, you will see something we call sidecars, which I will talk about later. For now, think of a sidecar as a way of deploying artificial intelligence modules and other applications alongside existing workloads and containers on the Blue AI platform. At the end of this demo, I will speak to how this unique feature allows a client to build custom solutions by integrating their application directly into the Blue AI data warehouse. And finally, at the bottom of the screen, you can see the BlueFlows that we described previously. BlueFlows allow you to create repeatable ingestion workflows that will bring the data into the platform. Let's imagine a simple scenario. A researcher working for a coastal zone management unit is trying to better understand the composition of the local water column and what factors are contributing to either the health or marine vulnerabilities off of their coastline. They may begin by conducting a broad search for public data and look for water column information. Immediately, our AI-enabled search feature returns a series of datasets about water column information, including data from SOFAR buoys, NOAA datasets, and others. Any of these can be selected and added to their databook. They can also access private data which they have permission to access. In this case, they have searched for two data sets that they have credentials to use, and they add both files to their databook. Next, they ask Blue AI to simply tell them what is in these two files. Blue AI starts breaking those data files down, applying that information to our Data Insights AI engine, which is going to provide a distribution of the data and suggest the type of things that would be possible to explore further. As you can see, Blue AI has returned a review of the data, including some important quality issues to note. For example, where the level of data completeness is missing data, especially in this case of nitrate, which appears to have a significant number of missing values. It also provides some possible analyses and questions that the researcher may choose to ask, such as, are there specific layers within the water column that demonstrate unique characteristics regarding temperature, salinity, oxygen, etc.? Our researcher continues with a broad question. How does seawater temperature, salinity, dissolved oxygen, and other measured elements trend over time? In just a couple of minutes, Blue AI returns a series of graphs displaying the trends for each of those data elements over time, in this case for both upper and lower layers of the water column. Blue AI also provides immediate insights into the data. For example, notice next to the nitrate measure, Blue AI notes sparse data but indicates variability. Peaks might relate to biological activity or runoff events, or how seawater temperature displays a similar seasonal pattern across both upper and lower layers of the water column. It then provides a final summary of the information suggesting that this analysis may serve as a basis for more detailed studies, particularly focusing on causative factors for observed fluctuations or the relationship between parameters. Not a bad idea. So, our researcher decides to compare what is different about the measures between the two water column layers. Immediately, Blue AI summarizes the analysis, noting both the differences and what may be influencing them. For example, it notes the lower water column layer has more stable salinity reflecting deep ocean currents with less terrestrial influence. What is important to note is that all of the Python code we use to generate these insights are always provided back to the user, so they can move that information directly into a sidecar, like a Jupyter notebook. They could also share this information with any other sidecar or other users that they may be collaborating with. Assuming this is part of a larger project, perhaps to assess the level of vulnerability of marine ecosystems to things like storms or heat events, our Data Insights AI has just saved this researcher hours, if not days of time, avoiding the need to download rows and rows of data and then spending hours using cumbersome analytics tools to clean, format, and analyze those data. Let me mention one more feature before I summarize what we reviewed today. You heard me talk about our unique sidecar technology, which allows the user to easily take the data, charts, and code generated by Blue AI and immediately start working in their favorite analytic tool like R, or to produce stunning dashboards from the data with a visualization tool like Superset. This is such a powerful feature. We have extended this capability so that an organization could build a persistent sidecar, allowing them to build custom solutions by integrating their own code with our sidecar technology. The client has their own private instance to search and analyze data, while our AI Insights engine works alongside their application on a shared platform. For example, a property and casualty insurance company could set up a persistent sidecar that would provide predictive modeling around the impact of climate change on farmers in vulnerable areas or the potential for flooding in low-lying coastal communities. The use cases are somewhat limitless, as they use our AI-enabled search to see what public and private data is available and decide if the data is something that would add value. The customer can add new data sources directly into their system, add and create new data books, and share any of that information with third-party colleagues to extend the value of this feature even further. Let me wrap this up. Despite the accumulation of petabytes of public and private data, a huge portion remains underutilized by science and industry. Why? Well, assuming you are able to find the data you need, there are even more hurdles in preparing it. and in some cases existing platforms often restrict users to specific analytic tools. We can do better. I hope this video demonstrated how Bluemvmt aggregates public and private datasets and make them discoverable through AI-enabled search. We eliminate the need for complex tools or coding, and our Blueflow editor allows users to ingest data from any IoT device easily. One of the things we didn't demonstrate is Bluemvmt's data versioning capability, as this happens in background. This is a foundational element of our technology stack and enables our data sharing and collaboration features, as well as other more advanced features on our product roadmap. But perhaps the jewel in the crown is our AI-enabled data exploration technology, allowing users to use natural language to quickly find and isolate the information they must have to inform the decisions they need to make. The benefits are summarized on this slide, but together we can extend this list even further. Thank you for your attention, and please visit our website to learn more.